Welcome to A-level physics, looking at alternating currents. Cells produce currents that travel in the same direction all of the time, direct currents. However, this is not always useful. For instance, transformers will only work if the current is constantly changing. An alternating current is constantly changing direction. It is normally sinusoidal. The frequency of an alternating current supply F is the number of cycles completed per second, measured in Hertz. The period T of an alternating supply is the time taken to complete one cycle. The peak values of current I0 and voltage V0 are the maximum values at the crest or the trough. They are equivalent to the amplitude of a wave. Sometimes we quote the peak to the peak value, which is of course double the peak value. We are now going to look at RMS values. Wouldn't it be great if you could just use the electricity equations you already are comfortable with for DC circuits in your AC calculations? The problem is, what value do you put in, because the AC values are always changing? Well, the RMS values of current and voltage are the answer to your problem. RMS values are the DC equivalent of an AC value. In other words, if you had two circuits, one DC and one AC, and you wanted them to use exactly the same amount of power, energy each second, then you would choose the DC values of current and voltage to be the same as the RMS values of current and voltage in the AC circuit. The power being used in each circuit is the same, so you can use all your old electrical equations. For example, V equals IR, P equals IV, and P equals I squared R. For AC circuits, as long as you use the RMS values of current and voltage, AC is no longer difficult. So how do you lay your hands on this magical value? Well, VRMS is equal to V0 over the square root of 2, and IRMS is equal to I0 over the square root of 2, where V0 and I0 are the peak values. Note, RMS values are less than the peak values of voltage and current. So when given an AC question, simply find the RMS values using the peak value and above equation, and then use your normal electrical equations.